Okay, hi, welcome kids. We are doing chapter 4, lesson 2. We are actually skipping lesson 1. Why? Because it's estimation and we're not going to be doing that. So we're just going to go to lesson 2, where you're just doing the exact thing. So lesson 2 is kind of not working. My mic is dying. Oh well. On lesson 2, we're going to be multiplying fractions with whole numbers. So we're going to look at the why the number becomes that way by drawing area models. We'll be drawing some tonight. Not on every problem, just on any 3 that you pick. But you have to draw 3 of them. Okay? So I'm going to start off the first example. Last year you learned about fractions. I know you multiplied fractions, or I think you added them. I'm not sure. But you did fractions. And we're going to take a look at this first problem. I want you guys to really pay attention because this is the why it happens, and that's really important so that you do well. Maybe you were taught just multiply numerators and then multiply denominators, but you don't know why the answer is the way it is. So this is teaching you why it actually turns out to be that answer. So on the first example, we're going to look at 3/5 times 4. Sometimes you'll see it the other way, 4 times 3/5. It doesn't matter. Okay? It might be this way, or the whole number might be this way. Okay? So you look at the whole number. It says 4. For our class, we're going to pretend they're 4 candy bars. They're 4 whole candy bars. So I'm going to draw 4 candy bars. We're going to pretend they're equal size. I'm drawing freehand, so it might not look equal, but we're going to pretend it's equal. So you understand where I got the 4 from here, the 4 candy bars? You're good? Pay attention. Then you're going to look at the fraction because you are going to look at the denominator for the hint as to how many pieces each candy bar needs to have. Here for the denominator I have 5. That means I'm going to cut each candy bar into 5 pieces. You with me so far? Mm-hmm. So I'm going to do, not on red. I'll do 4 slices, gives me 5 pieces. Good so far? We're going to pretend they're equal. So I'm doing this quickly. I know it doesn't look equal, but we'll pretend. Okay, so I have started with 4 candy bars, and you tell me I want to eat every single candy bar. And the babysitter says, no, you can't. You cannot eat all 4 candy bars. You're going to get a stomach ache. There's no way I'm going to let you eat 4 entire candy bars. How about this? How about I let you eat 3/5 of each candy bar? You might say, well, how much is that? We're about to find out. First, you look at the denominator, and you cut each candy bar into that many pieces. So 5 for each one. Are you with me so far?
Yeah.
Then you look at the numerator, because that tells you how much you're actually going to eat from each one of those 5 pieces. What number is the numerator? 3. That's how many I get to eat from each of these. So 1, 2, 3. I'm shading it for each candy bar. That's each one. So there's 3. We're not going to make noises because we have to focus here and we're videotaping, okay? So 3/5 of each candy bar. You with me? That's how much you're eating. How many total pieces is that? Talk with each other.
12.
I heard 12. 12/5. You're eating 12, and there's 5 in each of these. That's an improper fraction, and I'm supposed to talk with each other? Right, so what do we do?
5 divided by 12. 2. 10.
And I get
2.
2/5. 2 and 2/5. Well, let's see if that's true. Eyes up here, don't blink. Look real close. If I was to just add and put them all together, if I take this piece here and put it here, this piece here, put it here, that piece, put it there, and then this piece and put it here, how many whole candy bars does it say I'm supposed to have? 2. And the fraction was?
2/5.
2/5. I get to really eat 2 whole candy bars and 2 out of 5 pieces from an additional one. So I get 2 2/5 candy bars. Do you see that? This is an area model, and tonight you have to draw 3 of them. There's 10 problems. So I asked the kids, what's fair? Somebody said, we only draw 2. Some kids said, we should draw 5. And I said, let's compromise. How about you just draw 3? And they said, okay, that's a good number. So we'll draw 3, but we get to pick which 3 we're drawing. Fabulous. Pick any 3 from tonight's 10 problems, and you draw 3 area models. Now we're going to try another one together. This one you're going to draw with me. Okay, first, we're going to look at the whole number. How many candy bars do we have here? 2. So go ahead, draw 2 rectangles. Does it all look like that? Is you all drawing that? Turn to your neighbor or somebody in your group and tell them how many pieces each candy bar will have. Go ahead.
5.
I heard it. Show me with your hands. How much is that?
5.
Yes. Okay, now section it off 5 pieces for each candy bar. Go ahead. Now turn to your neighbor and say how many pieces you will color or shade in for each of those candy bars.
2.
Go ahead. You're going to show me this on your whiteboard. You're going to hold it up in a second. So shade in 2. Should look like that. Everyone hold it up. I want to see that you did that. Yes, I'm seeing it there. Yes, thank you. Looking good. Thank you. Okay, now the last part. We're coming to the answer. How many total pieces did you shade in? Kids, write that as your numerator. Go ahead. And your denominator is how many you have in each candy bar. So how many pieces do we have in each candy bar? 5. That should be your denominator, right? What? Can you tell your neighbor what was your final answer? I heard it. Say it louder.
4.
Excellent. You shaded 4 because that's all you're going to get to eat out of
5.
5. If you were to put these 2 down here, erase, erase, 4 out of 5 total pieces is what I'm going to eat, right? Now you're going to do the next one on your own again. And we'll see you